Welcome to Click for IB Biology. We are studying C3.1, the integration of body systems. And in this particular example, this particular video, we're going to be looking at a pain reflex, which is an integration of the sensory system with the motor system in a reflex arc. There's a PDF of this presentation that's linked in down in the description of the video. You can annotate that with your own notes, and then we have 10 questions with answers that you can use to chart your own progress. As mentioned, the pain reflex arc involves being able to detect changes in the environment, which are the stimuli. And this would be then transduced by a receptor structure in the sense organ into a nerve impulse that will travel along the sensory nerve. The impulse will enter the central nervous system, and the response is integrated through the action of a relay nerve that immediately sends the impulse out along a motor neuron. And so the sensory input is not primarily relayed to the brain for complex, time-consuming decision-making. Rather, we need a rapid response here to protect the structure. So the flow of the information is from the sensory nerve through the relay nerve and immediately out along a motor neuron that will end at a muscle as an effector. The contraction of that muscle provides us with the response, which is the movement of the limb away from the stimulus. And so we have this arc of information flow, which is the pain reflex arc. If we then try to locate this within physiological structures, of course, the idea of touching a structure with our hand, which is painful, a sharp object, for instance, the pain receptor would be in the finger. The sensory nerve would be traveling up the arm and into the spinal cord, where, of course, we would locate the relay nerve. And then immediately, the motor nerve would be emerging, is coming down into the arm from the spinal cord. And so the information flow is upwards across the relay nerve and immediately out along the motor nerve to the effector muscle. And so it's only the spinal cord which is involved, not the brain. And this gives us a faster, protective survival response, reducing the threat of damage to the tissues. If we look at this in a little bit more detail, we can see here we've got the nerve ending and the source of the pain. Down here we have the arm with the neuromuscular junctions and the effectors for the response. And this large image here, drawn out of scale, is a cross-section of the spinal cord showing the dorsal root with the sensory nerves going in, the ventral root with the motor nerves coming out, and the intermediary neurons or relay neurons located more centrally here, forming synaptic junctions here and here, within the depths of the cross-section of the spinal cord. So the information flow then is the transduction of the pain by the nerve endings here, creates a nerve impulse that travels along the sensory nerve. As mentioned, it passes through the dorsal root, traveling up and into the depths of the spinal cord. There will be a synaptic junction between the sensory nerve and the relay neuron. The relay neuron then conducts this impulse in a very short period of time to the motor nerve. And this occurs within a region of the spinal cord, which is often described as being the gray matter. The grayness is a consequence of the number of synaptic junctions. The motor nerve is then innervated. The impulse travels along that at approximately 100 meters per second to the neuromuscular junctions of the arm, where the muscle contraction produces the response. And in this way, the finger and the limb is protected from the damaging effects of the painful object here. So that's a simple integration of the organ systems. There's a chance to subscribe to the channel in the center here. Greatly appreciated. Playlists on the right hand side, and the next video is linked in to the left there.